Good day and welcome to another topic for PLC, basic PLC programming. And today we will be introducing you to Introduction to PLC Programming. Introduction to PLC Programming. So we've been talking about PLCs in the other lessons. And all this while, we've been talking about the user-defined program. You instructing the PLC exactly what and what not to do, because you are the brain behind the PLC. So when you program the PLC, and then whatever you program to the PLC is what the PLC gives you. So it's just like the normal, traditional way they say, garbage in, garbage out. So whatever you give in is what the PLC will give you. So here we are going to learn on some of the programming languages. Introduction to PLC programming languages. So someone will ask, how do you program a PLC? Is he using the C++? Is he using Java? Since you say it's a computer. Is he using Python? What programming style is the PLC using? So today we are going to introduce you to those programming languages, and there are 5 standard languages that are being used to program the PLCs. One of them is what we call the structured text. This is for information, structured text. We have sequential function charts. We also have the instruction list. Instruction list. We have the function block diagram. We have the function block diagram. So this is called the SFC, and this is called FBD, function block diagram. And the 5th, but not the least, is the ladder diagram, or some may call it ladder logic. Ladder logic. Some will call it ladder logic diagram. Okay, so whichever one. These are the 3, or rather the 5 basic standard languages that can be used according to IEC. All right, so, but the popular one is the 5th one, which is the ladder logic diagram. This is the most popular kind of programming. Not that you cannot use this, but most times while programming the PLC, you can make use, you find out that the ladder diagram is popularly used. Why? Because it relates, or it looks like the relay ladder logic. Remember, in the history of the PLC, one of the criteria was a programming language that will not be too different from what the technicians and engineers at that time in the 60s know about. And this is the ladder logic. And ladder logic has every similarities with relays. Okay? So while studying the relay ladder diagram, the ladder logic came up because it has every symbolical resemblance of the relay ladder logic. Okay? And it's called ladder because it has or looks like a ladder. It looks like a ladder, the way we have ladder. Okay? So it has rungs. So you have rungs. These are rungs. These are called rungs. R-U-N-G, rungs. Okay? And these are called power rails. Okay? Power rails. So you have it flowing like a ladder. Okay? So hence the name ladder logic. Because we still have to use logic to program this PLC. So this is how a typical PLC ladder diagram looks like. Okay? So this is it. This is called a ladder logic. So this is where I said this is the what? The power rails. And this is called the rungs. Okay? So you can label it as rung 0, rung 1, rung 2, and so on and so forth. Okay? And these are the what? These are the contacts, which we are going to be learning in a short while. These are the input contacts, and these are the what? These are output contacts. The input or output contacts are represented by a coil. A coil. This is a coil. So the coil is represented. This is represented as what? Output. And then other contacts are represented in this form. Now this is called a coil. And a coil is an output device. Okay? So all output devices like the valve, like the electric motor, the motor starters, the relays, the valve, the pumps, and all those examples which we learned in the previous video as an output device, those are what will be represented with this syntax, like a coil, okay? But not completely covered. So this is a coil, and this is known, for these other contacts, this is an output device, or output syntax. This is what? This is called examine if open, if closed rather. You can see this is open. So this is normally open. So for a relay, it is called normally open. In the PLC, we call it examine if closed. So like I said in the previous videos, the PLC is a workaholic. The PLC always scans the input, updates the program, and then have an output, updates the output. So it constantly scans this contact, which is an input device, to make sure that this has changed state. So that once it's changed state from normally open to normally closed, it updates the output device. So this is what? A closed contact. But in the PLC, we call it examine if open. So you can get that now. So you can see examine if open. So in the PLC world, in the relay world, this is known as what? Normally open and normally closed. That's NO and NC. That's what it means. Normally open and normally closed. So this is the graphical representation of the PLC, how the PLC looks like. Now, like I said, this is a ladder logic diagram. So which means that it makes use of logic as well. So you don't just write or draw anything based on that. You have to do what? You have to place it in the logic. So number one, we have the logic that we have. We have the AND logic. We have OR logic. Okay? So let's first of all look at these two. The AND logic. The AND logic, like from the logic gates that we have the truth table for AND gates. And in digital electronics, which is a course or a module you'll be taking, or must have watched the video, you will see that the AND gate is represented in this form. This is a symbol for AND gate. Maybe where here is A, B, and here is what? X. Okay? So if you have a truth table for an AND gate, you have A, B, and X. So if it's a two-input AND gate, these are all possible solutions. So it's either you have 0, 0, 1, 0, 0, 1, 1, 1. Now, remember, these are digital inputs. And digital inputs can have two states. Binary can have two states. And those states can be either on or off, true or false, yes or no, open or closed. These are just the two states that you can have. That's what it means. So this 0, 0 can mean no or off, while 1 can mean on. Why? So let's assume that 0 means off and 1 means what? On. So these are the possible two states any digital device can have, the two inputs. So if for an AND gate, when you pass this through an AND gate, the AND gate looks like the multiplication in our mathematics. So when you have 0 and 0, you have 0. 1 and 0, you have 0. 0 and 1, you have what? 0. 1 and 1, you have what? 1. So this is the possible outputs that you can have for an AND gate. So let us see how we can represent that AND, which is the relay, the same relay logic that was used initially while writing the ladder program. We could have two states this way, and then we'll have an output. Remember, we say this represents inputs and this represents output. So at the end of every ladder language, ladder programming, you must have end. Okay, you must have the end. So with this coil contacts, what it means is that power flows from here to here. I said this is the power rail. Now what it means that if we have power flowing here to have an output, let's say this is a push button, so we call it push button 1, push button 2. Okay, so if we have this open and this is open, so what it means is that if this is 0, 0, nothing, because this is open, nothing can flow through it, it means our output will be what? 0. If we have one of them closed, that is on, and then we have that's 1, and we have one open, it means that nothing can flow because this contact is what? Open. So we always have 0. Okay? So the second option could now be, what if we close this one and open this one? So this is open, this is closed. It means that nothing will do what? Will go across it. But if we should close this and close this, it means that this is 1 and 1. It means that the power can get to the output. So we'll have a 1 at the output. So this is how you represent an AND contact in the ladder diagram. So you can see they are all in a straight line. How about the OR function? The OR function can be represented, that is the OR function, can be represented as by this symbol, okay, this way, here and here, A, B, and X. Join the truth table for an OR function. An OR function, let us have A, B, and X of the relay logic. Of course, we also have 4 possible options with 2 states. The OR can look like the addition in the mathematics. It looks like an addition. So when we have 0 and 0 or 0, we have 0. 1 or 0, we have what? 1. 0 or 1, we have what? 1. 1 or 1 is same thing as 1. So can you see the truth table for the OR function? Okay. Now, how do we represent it in the PLC ladder diagram? We represent it in this way. We have, let's say we have an output this way, just like that of the AND. We'll have a branch. Call it a branch. We have a branch. So we have the branch. And remember, we are always going to what? End the program. Okay? So this is an OR function. Okay? Let's just clean this one and say this is an OR function. So let's say this is push button 1, push button 2, and then we'll have what? An output. So let's say output C. Let's just call it an output C. All right. So what it means here is that if both of them definitely is on, off, 0, 0, definitely nothing will be here at the output. But should we on any of them, or this can be on, this can be off. So what it means, the power can flow through this rail and go this way, and then it can get to the what? To the output. We can also have the power if this is when this is 1, this is 0. When PB1 is 0 and PB2 is 1, when we have PB1 as 1 and push button 2 is 0, okay, we are still going to have the power. If you have this as 1 and this is 0, you can have the power flow through this way and then connect. So either of them can be on. You can see either of these can be on. We're going to have an output. Either of or both of them can be on. We will still have an output. So the name is always captured there. Or, like an OR function, where we have an OR function. So this PB1 can be on, or PB2 can actually be on. They are going to achieve the same logic. Now, as we go on in the writing of the program, ladder program, we discover that we can have more complex programs where you find the OR function as well as the AND function all embedded as the same. So that is when it starts getting more complex. So when we look at the next program, the way we are going to address the program, that will take us to the next lesson, which is writing and addressing the ladder logic program. So we have said that we have 5 standard PLC programming language, and we've mentioned them as having the sequential function charts. We mentioned the instruction list. We mentioned function block diagram. We mentioned the ladder logic, and we mentioned the structured text. So these are about the 5, and out of those 5, the most popular one is the ladder logic. And we just showed you how the ladder logic looks. It has a power rail, it has a rung, and then it has some contacts, which we call examine if open or examine if closed, and then we have the coil and how they are arranged. So the next thing will be, how do we address it? Because different OEMs, different PLC manufacturers have their own style of addressing these contacts. So the way Allen Bradley addresses is different from the way Mr. Bushi addresses, is different from the way Siemens addresses. But once you have learned the semantics, once you have learned how to program one PLC, it's a question of just adjusting to the other manufacturers. Just like learning a computer. After learning a computer, probably Windows 98 or Windows 2000. And then at the end of the day, you come up to Windows 10. You wouldn't start going for another classes or another lectures from Windows 10. So what you do is to sit down, look at what changes in the software and how to do it, how to imbibe them in your programming. So we'll see you in the next class where we shall talk about writing and addressing of these contacts. Thank you, and I see you in the next class.